Alright, so in this video I'm going to be going over molar mass, what it is, how we can calculate it, and how we can use it. So the molar mass of something is just the amount of grams that something weighs if you have exactly 1 mole of it. So if you have 1 mole of iron, how many grams does it weigh? If you have 1 mole of water, how much does it weigh? It's 18 grams, by the way. So in this way, it's kind of like a ratio, similar to Avogadro's constant. So Avogadro's constant said how many particles are there in 1 mole, and we know that it was always 6.023 times 10 to the power of 23. Whereas with our molar mass, we're going to be determining it from the periodic table. It's going to tell us how many grams there are if we have 1 mole of something. So the unit for this, as I've alluded to, is grams per mole. So I've written down a few different ways that you can write it here. I think the way you'll tend to see it in IGCSE is like this, whereas the way that I tend to write it is like that. But don't be worried about the difference, they all mean the same thing. So to calculate the molar mass of something by itself, so an atom, you simply look at the periodic table. So if you go into your browser and look up the periodic table, something like that, then if, say, we wanted to know the molar mass of vanadium, just look it up. It's 50.942. And then that's just the molar mass. In comparison, if you want to find the molar mass of a compound, it's a little bit harder, and you're going to need to multiply each of the molar masses of the different atoms that make up the compound and times them by the number of that atom, as you'll see in this example. So the question I've got here is, what is the molar mass of sodium bicarbonate, which is sodium hydrogen carbonate? So for this, what the molar mass of sodium bicarbonate is equal to adding all of them together, like this. So we've got 1 sodium, 1 hydrogen, 1 carbon, and 3 oxygens. And if we look this up on the periodic table, we would see that we have 23, hydrogen's 1, carbon's 12, and oxygen is 16. And when we add this together, we get 36 plus 48, which equals 84 grams per mole. Note that I only use the molar masses here to significant figures. So if you needed more significant figures, you might need to use more decimal places there. But basically, this is the grams per mole. And this will never change for sodium bicarbonate. Whenever you do something with sodium bicarbonate, the molar mass will be 84 grams per mole. So we can use that in our next question. So for here, like the previous video, I'm going to be showing you how to do these calculations using the cross proportion, as well as using an equation. So the question here says, a cake recipe calls for 1 teaspoon of bicarb soda, sodium hydrogen carbonate there. So it's actually used as a raising agent just because it can act as a base and release carbon dioxide. And then if you know anything about carbon dioxide, it tends to raise stuff and it makes your cake go up. And then it's not flat, which is great. So the second part of the question, how many moles of sodium bicarbonate are there, assuming 1 teaspoon weighs 11 grams? So again, I'll write out my information here. The mass of sodium bicarbonate is equal to 11 grams. The relative molar mass of sodium bicarbonate is 84 grams per mole, which we figured out on the previous page. And the amount, we don't know. So again, I'll start with the cross proportion here. So if from our molar mass here, we know that if there's 84 grams of sodium bicarbonate, there is 1 mole of sodium bicarbonate. Down the bottom, we'll say if there's 11 grams of sodium bicarbonate, there are n mole of bicarbonate. So, like in the previous video, if we do a ratio here, do n divided by 1 is the same as 11 divided by 84. So n equals 11 divided by 84, and that is 13.1. and round that up to how many significant figures you're working with. All right. So that gives us our answer. The other way that you can do this, again, mass is 11 grams, relative molar mass is 84 times mol. You can simply use the equation N equals M over mR. In this case, the mass is 11, the molar mass is 84, so we get the same answer as the previous page, which should not be that, it's 0.13. So this is our final answer, and they're the same. So going in the opposite direction now, if I say that the petrol tank in my car can hold up to 358 mol of hexane, which apparently it can, how many grams of hexane can I fit in my tank? So we know that the amount is 358 mol, and hexane, by the way, is C6H14. So we know the relative molar mass is 6 times the mass of carbon plus 14 times the mass of hydrogen, which is equal to 72 plus 14 equals 86 grams per mole. And the mass, we don't know. So again, from our cross proportion, we know that if we have 86 grams, we have 1 mole of hexane. And we have 358 mole and some number of grams. So if we do, I'll do a cross product for it to change. So we know that times that is equal to that times that. So we can say that n times 1 equals 86 times 358. So n is going to be equal to 86 times 358, 3,788. Make that an m as well, just to make it easier. And then if you want to simplify that, you can change it to kilograms like that. And this is our answer. And again, we do the same thing with an equation. Relative molar mass was 86. We say N equals M over MR, and we know that 358 mole equals M over 86. Therefore, M equals 358 times 86, which is equal to 30.8 kilograms. We get the same answer. Alright, so it's basically the same process as you're using with Avogadro's constant and calculating the number of mole, but instead we have a slightly different equation here, and we're just using grams and molar mass in comparison to number of particles and Avogadro's constant. So the final question I have here is how many atoms of hydrogen in 14.7 grams of ethanol, which is going to need the use of converting mass into mole and then mole into number of molecules. So for this I'm going to just be using the equations because it's a little bit faster, but hopefully you should be able to do this using the cross proportions as well. So to start off with, we have the mass of ethanol, which is this, is equal to 14.7 grams. You know, the relative molar mass is equal to 2 times 12 plus 5 times 1 plus 16 plus 1, which is equal to 46 grams per mole. Yep. And we have our amount of ethanol We don't know. So the first thing, and I'll also just say Avogadro's constant is 6.023 times 10 to the 23. So to start off with, I'll start here and say that n equals m over mr, which is 14.7 over 46, which is equal to 0.32. That's grams. That's mole, sorry. And then from here, we can just go and plug that into n equals n over Avogadro's constant. So 0.32 equals n over 6.023 times 10 to the 23. So that value there multiplied by 6.023 is 1.92 times 10 to the 23. Right, and from there, take this value we say that this is the amount, this is the number of ethanol molecules, and we know that the number of hydrogen atoms is equal to 6 times the number of ethanol molecules, which is equal to 6 times 1.92 times 10 to the 23, which gives us a final answer of this times 6. So that will be 1.15 times 10 to the 24 atoms of hydrogen. Alright, so hopefully all of that made sense. I've covered a couple of different permutations of the problem, but again, a lot of these equations you're going to find questions will require you to use more than one at the same time. So, for example, if you were given a certain number of carbon atoms in hexane, what would be the mass of that? If I had 7.079 times 10 to the 24 atoms there. How would you figure that out? You'd just do the reverse of the process that I've just done. So again, hopefully that makes sense. And we'll continue with gas to mole, so gas volume to mole calculations in the next video.